Hello there and welcome to Lower 6th Further Maths A-Level Pure Core 1 past paper June 2016. Here we are on question 3, an old FP1 question. So the complex number z equals 2 to a plus 2i. A is a non-zero real number. Find z squared plus 2z. Okay, so let's work out the z squared part first. So it's going to be z times itself. So don't be lazy here and just square the individual parts of z. Make sure you do z times itself. So this complex number times by itself again. It's a double bracket sort of problem. So expanding the brackets to get a squared plus 2ai plus another 2ai plus 4i squared. Simplifying I squared with a minus 1. That will turn this part here into a minus 4. So just grouping together the real parts and the imaginary parts, you get a squared minus 4 plus 4ai. But that's not the final answer. We've got z squared at the moment. We now need 2z, and we'll add those results together. So 2z is 2a plus 4i. So adding these two together, and we're going to get a squared plus 2a minus 4. Add 4a plus 4 lots on the I. Great, so that's our answer for part A. So part B, given that z squared plus 2z is real, okay, well if something is real, then it's going to have to appear on the Argand diagram along the x-axis. So effectively it's where the imaginary part is equal to 0. And vice versa, these can imply. So what we have to do here is we have to set the imaginary part of this complex number here equal to 0. So therefore a will equal minus 1. Okay, moving on to the next part here, we have for this value of a, so that's going to be minus 1 plus 2i. We're now going to use z as z equals minus 1 plus 2i. Find the values of the modulus and the argument for z, giving your answers in radians to 3 significant figures. Right, let's just draw out the problem so we can visualize it. We're at the coordinate minus 1, 2i, so we're up here. So the modulus, first of all, is this distance on the line here. So that's going to be the mod of z is going to equal minus 1 squared add 2 squared, which is going to give us root 5. And for the argument, we need to work out this angle around here. This is going to be our argument. So what I'll do first is I'll work out the angle on the inside, alpha. So that's going to be tan minus 1 of opposite over adjacent. And making sure my calculator's in radians mode, I get 1.107 there. However, the argument that I'm looking for here, arg of z, is going to equal pi minus this, as we're on a straight line and we want the angle from the real axis, the real positive axis, round to our complex number. And that will give me 2.03 to 3 significant figures. So mod of z equals root 5, arg of z equals 2.03. We can also check this on our calculator. Do excuse the red lines. Go to complex number mode, type out your complex number, and then what you need to do is you need to go to options, scroll down once, and you get to this option here. You want to press option number 1 here, and that will turn your answer into modulus argument form. And you can see here that we've clearly got root 5 as a modulus and 2.03 as the argument. The 4 won't round up the 3 there. Okay, the next question here is to represent all of these numbers on an Argand diagram. So let's start with z. We've already done that. That's up here. So this is z. I'll make sure I label all of them nicely. Z squared, so let's just go back and see what z squared was. Z squared was this bit here, so this is going to give us a number of minus 1 squared is 1, that would be minus 3 minus 4i. So let's move back, so minus 3 minus 4i, so z squared is going to be down here, and z squared plus 2z, that was the real number. So if we plug minus 1 into this formula here, minus 1 squared, that will give me a 1, minus 2 minus 4, and it will be plus 0i because it's a real number, so that's going to be minus 6, that will be minus 5 there. Okay, so going back, we're going to get a minus 5 that's going to appear over here. Z squared plus 2z. Okay, so describe fully the geometric relationship between the line segment OP. So P corresponds to the Z, so this is plot point P, so I want to correspond this line to the line segment QR. Q is the Z squared one, and R is this one up here. So the only difference between this coordinate here, the Z squared coordinate, and this 2Z coordinate is that it moves by a sort of a vector of 2Z, and this here moves effectively at a vector of Z. What I mean by Z is it moves left by 1 and up by 2, but if this is 2Z, it's going to move left by 2 and up by 4. So the answer to this question here is that OP and QR are parallel, and QR is twice as long as OP. The scale factor between the OP line is twice the is half of the line from Q to R. So we need to times the OP line by 2 to get QR. Okay, great. That's 13 marks in total for that question.